Hello everyone, it's been a while since we last met, and today's topic is integration tests. Let's start with how our Spring Boot application works, that is, how the client communicates with our server. We have a user who navigates to a specific endpoint. Accordingly, they send a request. The request comes to the controller. In turn, the controller has services that process the information received from the user. There can be a lot of nested services, so what happens next? After the information is processed in the services, it is returned to the controller, and the controller, in turn, returns the information to the user. This is the essence of integration tests, unlike unit tests, which check individual functions and methods. Integration tests evaluate everything as a whole, meaning the complete interaction with the system. There are both pros and cons here, as it can be difficult to test all services integratively due to the various scenarios that can unfold. But since we have security, everything will be a bit more interesting. In our case, the essence of integration tests is such that by testing the controller, we are also testing the services, since we are testing the complete interaction of the system. This means we will be running the full Spring context, and we will even be using a database. First, in the test folder, we will create a folder called resources. Here, we will create application.yml. In application.yml, we will write the following. If you have already dealt with Spring Boot tests, I think you are familiar with this. The essence is that, purely technically, we can write the same things that we had in the application.yml in the main Spring Boot application. But this is not a very good practice. It can sometimes be applicable, of course, but not always. And they often simply use an in-memory H2 database because it doesn't need to be created anywhere. We simply specify the application.yml, and in order for everything to work correctly and for H2 to function, we need to add a dependency. So we open the POM file, scroll through and add such a dependency. We immediately update Maven. We wait a little. So, everything is great. We have configured the application.yml. Super. Now, we will also specify create drop here. Simply put, a database will be created and deleted immediately after the tests are completed. Also, let's not forget that we have a database. We even have a table since we have create drop. But there is one nuance. We don't have any data. We fill the data using scripts. Let's see how to do this. We create a directory here. Let's say data. And here we create a file insert data.sql and write this value. Why are these specific data here? What is it related to? From the previous video, you remember, I think, that we have this login and this password. And also, our ID is not just an integer, but a UID. Therefore, to know what our ID is, we will write it down manually, like this. If we enter a regular password like 12345 here, we will encounter problems because our services work specifically with an encrypted password. So here we will fill this in this way. We can add many users, but one will be enough for us. Next, what else do we need to do besides this? We need a script that will clean the table so that our tests work both individually and collectively. Let's create a file here, and we'll call it plan up. Let's say point risk. We will use cleanup.rescl and simply remove all data. This way, we will ensure that our tests pass correctly, both individually and collectively. Now, let's proceed to writing the tests themselves. We go into the Valve controller and simply click here to generate test gun at 5. We select our two controllers and here we specify the Spring Boot test annotation. This annotation is needed to start the Spring context. Next, we have the auto-configure mockmvc annotation. This annotation automatically configures the mockmvc object, which is used for testing HTTP requests and responses at the controller level. Here we will define a private mockmvc, the @AutoWired annotation. We will also need our JWT service, which you will learn about later, also @AutoWired, and we will need object mapper, also @AutoWired. Great, also AutoWired. Great, great, great. Now, before the tests, we will need to run scripts. Since we have two scripts, we must use curly braces. First, we have data.linux.appsql, then we have insert data, data.insert data. Before this test, we will first perform a cleanup and then populate it with data. So we have a sync and test. Moreover, we will have both a positive and a negative test. In order to proceed, we need user credentials. Next, we specify the login as email.test. This is the same email that we mentioned right here. Also user.setPassword. And here we specify not the encrypted password, but the one that actually is 1, 2, 3, 4, 5. Great, we already have the login data. Now we need to use Object Mapper to convert our user to JSON. Naturally, an exception will be thrown here. Then, there will just be an exception, since our OCamLC will also throw an exception. Now the most interesting part, we will make a request to the database. Here I specify the JSON token because I want to get the token back. After entering the login and password, I receive a token and a refresh token. I want to get the token, and they will be useful for checking that this controller is indeed working. So we write perform mock request builders.post. We have a post request, and thus we perform a post request to the address auth.sync.in, specifying the content type as media type application.json and the content as user.json. Now we have an expected status. We expect the import status to be is. Okay, as we anticipated that we would receive the status, import. Entry turn, get request, get content as string. We also throw an exception here. We added, everything is correct, everything is good. Now we have received the JSON token, but we need to parse it back into an object. However, we have a special detail for this. gvt.application.dtl equals object mapper, read value, object mapper, read value, object mapper, object mapper, read value, object mapper, read value, object mapper.read value. Here we specify what we are reading and into which class everything will be transformed. Here we specify gvt.application.dtl perfectly. And this is where our JWT service will come in handy. Get email compared service get email from token. Spring context starts. Nothing works. Service. Get mail from token. Jvetal s indication detail. Get token. Well, now it's time to check. We run the test, and the Spring context starts up, and nothing works. I made a small mistake. It's not getRequest here, but getResponse. Let's align the code and run it. Everything is correct. Before we write a negative test, I would like to make a slight adjustment here. The thing is, a 500 error is being returned, which is somewhat incorrect from the application's logic perspective, as a 500 error indicates a server-side error. However, we do not actually have a server-side error. We have an authentication error. The person entered wrong username password. What will we do? To correctly return a 401 error, the person entered wrong data. We will do it like this. Response entity status.http status unauthorized.body now. The Spaniard's anti-status will create the status now. That's all. You can also fully customize everything here as it suits you and as you wish. Let's come back here. Just copy all of this and paste it. So, what do we have wrong here? It's natural. We need an exception. However, we will modify it a bit since the password has now been entered incorrectly. We will not have an OK status, and we will not return anything. We will have a status of unauthorized. Let's run it and check. The test has passed. Great. To ensure that everything is working correctly, let's run all the tests. Great. Now we need to conduct a test using the refresh token. This will be a bit more interesting. The thing is, we need to go through the entire first test, so to speak. And here we will make it a bit more interesting. Here we have refresh token DTO, refresh token DTO, refresh token DTO. Everything is correct here. Now we do it like this. Set refresh token. We take object mapper, array value, and read the token JSON using the JWT authentication DTO class. And now the most important part, get refresh token. Now we also create refreshToken.json and write value string and write refreshToken here. Now macOmsends.postAuthRefreshContentType.json refreshToken.json expecting OK token is now sending a request period by alpha 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 Rusin, and the expected status is OK. So everything is correct here. Of course, we can later retrieve the token and refresh token again from there and compare that our token does not match the previous token, while the refresh token does match. But I think that this is basically unnecessary. But if you want, you can also do it through assertion assert equals. But we need to run it and make sure everything is really working. So great. The refresh token test has passed correctly. All tests went great. Everything is done. Let's go in here and take a look. So we passed this. Everything is correct. We even passed this. And we also passed this. The essence is that there is a benefit to integration testing. In fact, we go here and see this. Right, and the point is that everything is being tested, as we are actually running a real Spring context. Without mocking the services, we are checking their functionality. That is, all our services operate as they do in the normal application mode. The tests are conducted in exactly the same way. We do not mock the behavior of the services. We use everything as if it were in a regular Sprint application. This is what we have tested, but we have another controller, and this one is a bit more interesting. Why is that? Registration isn't particularly interesting since we have access without authorization. But for all the others, we need authorization. We need a token. So how do we do this? Let's create some tests. I'll also quickly write the registration. Here we also need the Spring Boot test annotation. We need mockMVC and auto-configured mockMVC. Let's take the JWT service from here. This time we don't need it. We won't be using it. But we will use SQL here. Basically, we don't need it here and here. So let's create a user who wants to register. User.toSetFirstName. Let's say test.user.setLastName will be test1. And user.setEmail will be testneo.t@gmail.com. So it will be like this. We will have set password, for example, and that's it. We have created the user. We do not specify the ID. The ID is assigned by the service. Next, we also need to write it to JSON user.json using object mapper. It also throws an exception, as always. And now, with the help of mock.mvc, we have this post request, which has user registration content type as JSON. The content itself is user, and the expected status is OK. We also have an exception occurring. Everything is correct. Everything is good. Well, now let's check if it works. So we have access to registration. It should work correctly, and there won't be any problems with it. Since we have no restrictions on this endpoint, it will be a bit more interesting here. There are different ways to do this, but I personally will use this one. I will write a method that will return the token, which we can use to access these inputs. It will look like this. Private. String gets this token throws an exception userCredentials.dto. We write everything that was at the beginning. Let's not write it out. Let's take it directly from there. That's all we need. Next, we write login.json, for example, object mapper variety string userCredential.to. Now we have string.tokens mockMVC perform. As always, we have mockMVC request builders post, making a request to auth.sync.in content type.json get content.json. The content, of course, is login.json, and we return getResponse getContent.string. We receive the tokens. Then, using our object mapper jwtAuthentication.detail, we read our token, or rather, the tokens, and after that, we return the token. This is the method we will call in these two methods, and accordingly, we will gain access because of this. I can't claim this is the best option, but in my opinion, I wrote it, it works, and that's it. Now we will see how it works. So, we need the token getAccess token. Here, everything is correct. Now we just check perform.get. This will be user, and we need to extract this ID from here. We simply insert it here. Here we have the header, and inside the header, we write it like this. That is, this is authorization, this is the error, and the token itself. We expect the status to be okay as always and expect the JSON path email.value. We check that the mail matches. And run the test. The test worked. Everything is great. Everything is correct. Here we are doing practically the same thing. You can even just copy it. Naturally, an exception. Here we will have a user. And I think I have the email like this. And here we enter test.savakaimail.com. The same goes here. We change nothing. Everything works the same. So, to ensure a 100% check, we will run a test here. All tests have passed, and the tests are running very quickly, just so you know. At first, the longest part is the startup, but once Spring has launched, everything goes quickly and works correctly. Now, for completeness, let's run all the tests to ensure that everything is working correctly. Congratulations, you have written the tests. All tests are written, and everything works correctly. This is your integration testing. Most of the methods that we have in the application are covered here. Of course, it's likely that not all of them are. We need to look at the coverage, but most of the methods that are primarily used in the application are covered. That is, some exceptions need to be tested separately, preferably. Well, to be completely sure that everything works correctly, I hope it was interesting and clear. I hope you now understand what integration testing is and how to test Spring's security specifically through controllers. I also hope that this video was useful to you, that everything was clear, and that you will now be able to write integration tests for different controllers, not necessarily just Spring security. If you have any comments, if you noticed any mistakes that I missed, or if you have any requests or suggestions for the next video topic, please write in the comments. We read them. Also, stay tuned for a video on unit testing, specifically module testing, coming soon. Thank you all for watching. Make sure to subscribe, definitely give a like, and leave a comment. Goodbye, everyone.